Hello everybody, welcome to April 6th, 2020 Slope Field Notes. A slope field is a graph showing tangent lines for the family of solution curves of a differential equation. All that means is you're going on a slope field, you're going to have points and you're going to draw little dashes that show the slope at that point, because remember, tangent lines help you see slope at specific points, and then your differential equation is the equation for that slope to find that slope at a particular xy point. All right, so how this looks is you're given a differential equation, in this case dy dx equals xy over 4, and we need to sketch the slope field on this given coordinate grid. Now each of these points represent the point on the graph that you're going to try and find the slope. So if we are going through the points, say, -2, -2, we're going to use this table on the left to identify what our slope would be. To do that, we take x equals -2, y equals -2, and plug it into our differential equation. So if we plug that in, you get -2 times -2 all over 4. So that's 4 over 4, so your slope there is 1. So at the point -2, -2, our slope is 1. Now when you're drawing in the slope field line, the marking, a slope of 1 represents about an angle of 45 degrees. So at -2, -2 here, you're going to want to make sure that you're aiming that little dash mark kind of towards the origin, basically. All right, let's look at our next point. We have a typo. That's supposed to be -2, -1 there. So -2, -1, again, we plug it into our differential equation. So we get -2 times -1 over 4, which is 2 over 4, which is 1/2. So at the point -2, -1, our slope is 1/2. So that one's going to be a little less than 45 degrees. So it should look a little flatter. All right, our next point we're going to look at is -2, 0. So if x is -2, that's going to be -2 times 0 over 4. That ends up being 0 over 4, so just 0. So a slope of 0 is just a flat line. Then at -2, 1, it's going to be -2 times 1 over 4. So you get -2 over 4, so you get -1/2 for your slope. So it's going to look like the same angle as at -2, -1, but now a negative slope. So do your best. Oops. This pen does not like to cooperate with me all the time. So something kind of like that. And then -2, 2, at that point, it's going to be -2 times 2 over 4. So -4 over 4, so -1. So it should look something like that. So using that example, what I'd like you to do now is go ahead and see if you can fill in the rest of the table and then draw in those slope field lines at each point that you find the slope value of. So pause here, do that, and then start playing again, and you should be able to see if your solution matches mine. Okay, so what you should see is here is your slope field on the right, and then these are the table of values you should have on the left, so double check that and make sure you have that right. And the next question I have is, what kind of function seems to be pictured by the slope field? So what's key to remember here is each of these red dashes on the coordinate grid represents the slope at each point. So this technically gives you kind of the shape of what the original function will look like if you're going through a specific point. So what I mean by that is, if we were going through the point, let's say 0, 0, these slope fields, this slope field, will then tell you kind of, okay, there your slope's going to be 0, but then it gets a little steeper as you go up, and then a little steeper as you go up that way. And then same here. steepens out as you go that way. So it kind of gives you what the shape of the original graph would look like based on the slope field. So this makes a parabola. So this seems to be what we would think would be a quadratic function. Now let's see what our actual function is. That it would look like this blue line right here, kind of like a widened parabola. So if we go back, if you remember, in order to figure out what a solution to the differential equation would be, is we use separation of variables. So we're going to separate then integrate. So we started with dy dx equals xy over 4. And then we need to separate. So we're going to multiply both sides by dx. So we get dy equals xy over 4 times dx. Then we want just x and dx over on the right. So now since we're multiplying by y there, we want to divide by y. So we should end up with 1 over y dy equals 1/4 x dx. All right, so now we've separated. Now we need to integrate. So really dig into those toolboxes in your brains. The integral of 1 over y dy is going to be natural log of the absolute value of y. And then the antiderivative or integral of 1/4 x dx is going to be 1/4 of x squared over 2 plus c. Next, we need to solve for y. So we get e to the ln of y equals e to the, let's see, that ends up being 1/8 x squared plus c. All right, e to the ln of y, e and ln are inverses, so we're just left with y. Now remember, when you're adding exponents, that's like the same as multiplying. So e to the c times e to the 1/8 x squared. And remember, e to the c, if you're doing e to a constant, you're just going to get another constant. So this is y equals c e to the 1/8 x squared. So this would be our general solution involving that differential equation. If you wanted to check this, you could pick a value for c or pick a point, plug it in, find c, and then graph it. So I would take out your graphing calculators, even just try and graph e to the 1/8 x squared, and you should see. All right, next we're going to look at analyzing slope fields. So if you're given a slope field, what kinds of things can we deduce? Can we find our differential equation that's representing that slope field? So first, let's look at this one. What can you deduce from reading this slope field? So basically, one thing you're going to want to look at is, okay, if I went through a point, here's where I level off, and then it looks like the slope gradually increases and then decreases on either side there. So that looks like what would represent a cubic function. So our function would most likely be cubic, which then, if you're thinking in terms of derivatives, if we have a cubic function, then that means our derivative would probably be in some form of a quadratic. That can kind of help guide you in this next question then. So which of these is most likely the differential equation? So what you're going to want to do is pick a couple of test points, usually in 2 different quadrants, so you can kind of test it out. So I'm going to pick one in the second quadrant, so a point -1, 1, let's say, and then I'll pick -1, -1. And I'm going to test out both of those points in each of these differential equations and then compare it on my graph. So -1, 1 is right here. -1, -1 is right here. So what I should be seeing is that I'm getting the same slope, and it's probably about 1/2. because it's not quite pointing at that origin, it's a little flatter. All right, so let's test it out. So dy dx, I'm going to put -1 in, so I get 0.5 times -1 times 1, which is a -0.5. Well, if I look at -1, can already see that that's a +1/2, not a -1/2. So we know it's not going to be that equation. So we don't even need to test the other point. And then if I look at part B, x squared over y, let's test -1. So -1 squared over 1 equals a +1. Okay, well this we thought was a +1/2, but we can't totally rule it out because sometimes these aren't exact. So let's test out our other point. So let's test out -1. So -1 squared over -1 equals -1. Well, you can see at the point -1, your slope is a positive, not a negative value. So we can rule this one out. So you know it probably has to be this one. Let's just double check and make sure. So 0.5 times -1 squared. So that's going to be +1/2. And then at the other point, it should be the same value because x is -1 there as well. So this slope field represents this differential equation. So to finish up today, some tips for analyzing slope fields. Pick test points. That's going to help you a lot. And then 2, 3, 4, and 5 just give you some other hints that you can look at when you're looking at those slope fields. You can base it off of what quadrant you're in. You can base it on whether slopes are 0 or undefined, vertical lines or horizontal lines. Yeah, so just make sure you read through those and use those to help you through your daily task today.